Hello, and welcome to the June 1st, 2021 Bitcoin Cash Network discussions. Today's topic is PMv3, a new transaction format being proposed for Bitcoin Cash. Presenting today is Jason Drezehner, author of PMv3. His other open source work includes cash channels, cash tokens, Bitauth, and libauth. Our other participants for today's discussions are Tom Zander, founder of Flowee, Benjamin Scherrey of Biggest Fan Productions and Proteus Technologies, Richard Brady, Bitcoin and Telecoms developer and consultant, and Rosco, software engineer at GeneralProtocols and creator of Truffle Suite and CashScript. These discussions follow a 5-section format. For each section, the presenter will open the discussion with an overview, after which we'll open up the floor to the rest of our participants for questions and comments. Participants are encouraged to direct their questions primarily to the presenter and to make sure comments encourage productive responses. Those section topics are as follows. 1, the proposal's problem statement and or use case. 2, the properties of a good solution and or implementation. 3, the proposal itself and how well it fulfills those requirements. 4, the cost of the proposal to the BCH ecosystem. And 5, the relevant stakeholders and any public support. So Jason, please go ahead with a description of the problem statement and or use case of PMv3 when you're ready.
Awesome. So PMv3 is a version 3 transaction format. We call it PMv3 just to differentiate it from any other possible transaction format proposals just for now. But it is a version 3 transaction format proposal, which would allow us to use the existing smart contracting features of Bitcoin Cash to do a lot of the things you can already do on systems like Ethereum and other global state networks, in summary. So decentralized finance applications.
Very good. So could you tell us a little bit about, without getting too much into the weeds, what specific kinds of use cases are enabled by these decentralized finance? Now, some people are probably already familiar with it, but if you can give us just a basic overview.
Yeah, so basically the Bitcoin Cash virtual machine, so the inside Bitcoin Cash, the way that transactions work, there's a programming language that lets you specify who can spend a certain sum of money, and you can specify that in this virtual machine language. And that language is actually very powerful already for Bitcoin Cash. It's actually sort of just a packaging issue with how the transactions work that prevent us from allowing contracts to sort of reference each other in a safe way, a safe and scalable way. So what PMv3 does is allows you to add a hash of the contract, the script, the unlocking byte code in a section of the transaction. And
actually, I'm going to interrupt you even there, Jason. Yes. Sorry to interrupt. So this is getting actually into the weeds of how the implementation is, but could you maybe just talk a little bit about, so what are like the direct applications? So I know you've talked a little bit about prediction markets. And so if you could talk maybe just a tiny bit about those, and maybe also, I believe tokens are also something that this makes possible.
Yes, so this would allow us to build token applications, things that you do, ICOs for and stuff. This allows us to build prediction markets and other information markets, synthetic assets, things where we kind of binary contracts and other synthetic assets that represent real world assets on chain, decentralized exchanges, really anything that's kind of, as far as we know, anything that's being built on any other cryptocurrency platform should be possible in Bitcoin Cash with this.
Very good, thank you. So I'll open it up to everyone else now, and I realize maybe there won't be too much to say about this, but would anyone else like to ask any questions specifically about those use cases and the value of the use cases, and specifically the problem statement that we've covered so far?
Well, I'll go. So that's certainly quite a big claim, and it's an exciting one. I think one of the reasons I've spent so much time trying to dig into PMv3 is just to establish whether you're actually right about that or not. And so it's there's also a bit of a paradigm shift in terms of the way one thinks about what smart contracts would look like in PMv3. It's not sort of a replica of the Ethereum virtual machine, for example. So I'm very excited about all these potential applications. At the same time, it's really hard to try and imagine what they would look like using PMv3. So having concrete examples is great, and cash tokens is brilliant in that way. So I'm looking forward to seeing some more detail on that.
Thank you. Yeah, and Richard's review has actually been really, really helpful already. There's been some, we made some improvements to the spec from it. And as Richard was saying, the change is, it's quite a different paradigm actually than the global state network. So Ethereum and several other cryptocurrencies, their transactions can actually interfere with each other, and that causes some scaling issues. And what is quite different about the Bitcoin Cash strategy in general is that transactions are atomic. They don't interfere with each other than the double spending resolution. And this contracting ability does not interfere with that scaling ability. So in one sense, we can build all the things that you would be able to build on a global state system, so far as we know, but the scaling advantages of that isolation are not given up. So it does, from a developer's perspective, it is a little bit harder as a mental model to develop an application that scales like this, because each contract holds its own state, basically. And that makes it quite a bit more mentally taxing to develop an application. But the benefit, of course, is that it scales very well.
Thanks. And so that gets a little bit into what the properties of a good solution and implementation are, the scaling properties. Ben, did you have a comment about just the general use case or problem statement before we move on to that?
Yeah, no, I think it was covered already.
Okay, great, thanks. So that's at least one there. Is the I'm sorry, Rosco, go ahead.
Yeah, I'm not sure if this is already the right place, but like you mentioned, it's gonna be mentally, or like the mental model for the developer is quite a bit more difficult. So what do you think? What kind of people will be the ones that are like building, are going to be building on top of this if it's implemented? Like, is it going to be like node developers or people like regular JavaScript developers? What's kind of like the skill level where you have to be to really build something on top of this?
Yeah, it is a little hard to envision early on. I imagine it's kind of a crowd that is not yet super visible, but a lot of the people that are already building applications on networks like Ethereum, I imagine will want to take a look at a more scalable option for certain types of applications that already exist. And it's a lot like when you're developing for a company in normal internet world. It's much easier to build a monolithic application. It's quite a bit more complicated to build one that scales very well, scales horizontally, globally, and stuff. So you do sort of have an upper echelon of things that kind of rise to the top of really top quality engineering work that scale very well, and those are the kinds of things that are going to be deployable on Bitcoin Cash.
Yeah, if I can add to that, that's actually my main issue, or not issue, my main observation for our team as we've been trying to get into this PMv3 stuff, because we're a development shop. And to answer Roscoe's question, so for Ethereum, for example, they designed Solidity to be based off of JavaScript in order to make it easier for programmers to get in. I think this was a huge mistake, because it made a whole bunch of people who write applications like the next Facebook killer, right? If you get some strange thing in your Facebook application, your Facebook killer application blows up, you just reload the browser. But instead, what we're really seeing in these systems, you got 3 lines of code in the DAO, and if this line was up here versus here, the DAO would not have exploded. It's going to require a different level of disciplined coder to do these kind of things. And specifically with what's being introduced in PMv3, the complexity of the code, the expressibility of what can be done on in the Bitcoin Cash ecosystem is exploding. Now if you're a Bitcoin Cash developer, you're used to programming mostly in kind of like the assembly language of Bitcoin, and it's very clear this kind of puts that out of the realm of being reasonable. Now, I'm thinking, Jason's examples are in CashScript, right, which is a language that compiles down into the assembly language of it. And this opens up, and I'm a language designer. In fact, the Actor Fourth group that I run is to build a language that targets this kind of stuff. So we're now going to have to use languages that are extremely safe, very, very type safe, require and impose a correct by construction discipline, rather than what's been allowed to run on Ethereum and other blockchains. And that's a huge shift, and it's also going to make, I believe, these smart contracts on BCH far more reliable and resilient to those kind of attacks.
Very good, thanks. If Jason, if you don't have anything to add to that, then let's move sort of officially on to the properties of a good solution and implementation. So maybe it would be good, I know you have some notes here on other solutions that are currently in the works for implementing similar types of things, if not in a similar way. Could you maybe do a bit of a comparison on how the implementation of PMv3 compares and contrasts to those, like Smart BCH, Solidity, Mitra, I forget, group tokens, all those things?
Yeah. So there are a few different ways we could do this. There are a few different ways we could get this expanded functionality. One thing that I think is very cool about the strategy in PMv3 is the existing virtual machine is actually already very powerful. And it's sort of a happenstance of how transactions are packaged up that makes it not currently capable of looking backwards in the validation. So we can validate the current transaction and we can validate from the future forward. But validating backwards is not possible just because of kind of a packaging issue. So with PMv3, if we solve that issue, so we can get quite a bit of functionality, surprisingly, just by adding a hash. And then the existing virtual machine works quite well. So the differences, so Smart BCH is a BCH sidechain, which runs decentralized applications that are designed for Ethereum and for the Ethereum virtual machine. So Smart BCH alone requires a trusted peg between the sidechain and the BCH main chain. But with PMv3, that Smart BCH peg could actually be designed to rely on a more secure BCH contract rather than the trusted peg. So they are not, I wouldn't say that they're alternatives, they're very complementary. But Smart BCH is really designed for existing applications that have already been designed for that Ethereum model, kind of as Ben was mentioning. So the other things, so Solidity and Mitra are both virtual machine proposals for sort of wholesale replacing the existing underlying virtual machine in Bitcoin Cash. Or in the case of Solidity, that one was proposed almost 6 years ago, I think now. And development is sort of ongoing. And that gives you a sense for why they're alternatives, but a little bit further out. They require a lot more research before we would want to swap something out like that. Whereas with PMv3, the existing virtual machine is a well-known quantity. It's well understood and well tested. So we're not very concerned with making it slightly more powerful in certain ways. Group tokens is a hard-coded token proposal for Bitcoin Cash, which would sort of add a token space to transactions. It's a little more complex than that, but it would allow us to do some of these more advanced contracts also. So there are certain parts of it that are an alternative to PMv3. But then, of course, things where you're having contracts that interoperate, where you have a contract that reads another contract and such. a lot of those still would require something like PMv3. So in a sense, a lot of what can be done with group can also be done in contracts alone with PMv3. But group could make some of them more efficient, so that's nice. Something that additional research is required there. And then I should note, there's one other kind of high level alternative we could consider, which isn't really being proposed, but if we had introspection opcodes that allowed a transaction to look into details about its parent transaction, that would also solve what we are trying to solve with this PMv3 stuff. However, that would be quite a bit worse for scaling because it would basically increase the size of what is currently held by nodes in the UTXO set. It would increase that massively for probably not enough gain. So no one, that's not been proposed, but as kind of an explanation for why we don't want to do that, that would require quite a bit higher validation costs. So as an alternative, PMv3, we're able to simply add a hash to certain transactions, and then those transactions pay their own cost. They wouldn't increase the general validation cost of the network, but instead they'd be 32 bytes more expensive themselves, which properly incorporates the cost of the network of doing the hash.
Very good, thank you. And if I may maybe summarize a little bit, because I think you touched on each of these, but you have written here that a solution should, one, utilize as much existing infrastructure as possible. And so that might be the virtual machine, minimizing the implementation cost. Of course, we didn't talk too much about that, but that's also from reusing infrastructure and then avoiding technical debt. Is there anything within those three that you think you haven't covered before I open things up to everyone else?
Yeah, that summarizes well.
Very good. So would anyone else like to ask any questions about that or challenge any claims or, discuss?
I'll add in here,
okay,
if you don't mind.
Let's go ahead.
So my goal here in this is functioning is looking at how Bitcoin Cash, as we have been using it for a while, is affected by the changes. If there's any negative consequences for scaling, if the complexity is being increased unreasonably, and other such things. So I've been looking at that a lot of time from a lot of different angles with Jason, and we've dug in minuscule stupid details, and I think we're very happy about how it really extends the vision of the original Bitcoin in that it allows you to do more with the tools you already have. So it's basically removing obstacles instead of adding features, and that's, in my view, the best way of looking at it. It's just making a small change that removes some obstacles that allows us to do more. And from that point of view, I think this is the most sane way to go for the coin. And a lot of the alternatives are, a new VM is just a massive undertaking, and that kind of options doesn't make sense to me. So that's my point of view here.
Appreciate the comment. Does anyone have a response?
Yeah, I'll just echo Tom's statements. I mean, it's really impressive what Jason has been able to eke out of a non-Turing complete computation engine. That's just like, wow, from an engineering perspective. I'm looking at this as, how does this thing work? Holy crap, it really works. That's pretty cool. Although I tell you what, our team is still getting our heads around it. We still can't follow through all the examples, but we're working on it.
Very good. So, Jason, now maybe it would be a good time to give a high-level overview of what the actual changes are on at least a slightly technical level, and then explain just a little bit of how that works to enable the use cases you've described.
Awesome. Let's see. Can you all see my screen?
Yes.
See my cursor and stuff. Okay, so the I don't have a PowerPoint. This is actually from the blog post. So this will be linked in the video probably, but it's the PMv3. This is a thorough, detailed walkthrough. So if anybody's curious, I recommend you take a look at it. But I'm just going to show a little graphic to get a good sense of what's going on. What PMv3 allows is a couple additional fields in the transaction. Kind of the most important one is the detached proofs. So we call them detached proofs. What's happening? Can you see my cursor?
Yes.
Yeah. Okay. So what's happening is in a version 1 or version 2 transaction, if you're trying to inspect some element of a parent input in that transaction, what you do is in your proof information, you have to push the contents of the parent transaction and then pick it apart sort of to demonstrate what's going on. And in the existing transaction format, that becomes an issue because in your here's our current transaction, you'll have to include the parent transaction, but the parent transaction actually includes its grandparent transaction, etc. So if you're trying to inspect backwards, every time you step forward again, your transaction gets that much bigger, and it becomes completely unreasonable after even just a few transactions. What we do in PMv3 is instead of having to include the grandparent transaction, the grandparent transaction could optionally have chosen to use a detached proof. And so instead of including its own proof information here, it hashes all of that. So you can see the red block is just a hash now. And the hash of that is the contents of all this stuff. But by hashing it, now the parent transaction is actually a fixed size. Each time we step forward in this program, looking backwards requires just a fixed 32 bytes instead of an exponentially growing amount of information. So interestingly enough, inside that hash is everything that was there before. And inside of that, there's something with a hash with everything that was there before. So in a sense, like the whole history is being compressed into this hash at each step. But the part that's super wasteful is abridged. We are sort of compressing each past proof in each new step. So that is a high-level summary of what's going on. If you're curious more about the details, I encourage you to check out this blog post where I step through what is a contract and what's a covenant and some of the other details, even get into some of the applications on chain token sales, transferable synthetic assets, decentralized exchanges, and prediction markets and other information markets. And I've written quite a bit more about those. And then I compare a little bit with Ethereum, which is kind of a global state paradigm where transactions can interfere with each other, and that is the scaling issue. And with Bitcoin Cash, we've got a stateless network with stateful covenants. So instead of it being a network scaling problem to build an application, the developer building the application has to think about their scaling a little bit more. So it shifts the burden from the network to the developer of the application. But in exchange, we get Bitcoin Cash's scalability there. So is that any questions on that?
Well, maybe what I'd like to do, if I may, Richard, excuse me.
Yeah.
Well, we've already done the sort of use cases, in the first section. Could you maybe spend just a minute on each of those that you just glossed over and explain for any of us who
Yes.
don't know, what really basically, okay, on-chain token sales, what does that mean? What does transferable synthetic assets mean?
Yeah, so kind of the simplest one is on-chain token sales. We can build a covenant that sells its own tokens, that conducts its own IPO, and we can even do interesting things like conduct continuous liquidity events, like continuous buyouts, which could be very cool. So there's that. The transferable synthetic assets. When you can hedge in the Bitcoin Cash ecosystem with an adequate oracle, which might be provided by a prediction market, you can hedge pretty much anything in the world, and you can replicate any kind of portfolio just in the Bitcoin Cash world, using a mix of derivatives. Basically, it's not simple, but what's cool is with PMv3 is we can make those synthetic assets transferable. So the things that are already happening with any hedge and D-token right now, we can make those transferable from different end users, so that they become a lot more like synthetic assets already existing in the real world right now. Decentralized exchanges, we can build exchanges that trade in those synthetic assets, and we can build exchanges that trade in other tokens that are built on the Bitcoin Cash ecosystem. What's cool about that is that these markets could enable borderless global uncapped investment in any stock, commodity, currency, or other asset, because they are, by nature, they are on the internet. They are not in a single country, or they're not in a single institution. And then prediction markets are these are betting on the outcomes of events, but more interestingly, combinatorial prediction markets is what they're called, is where you bet on sort of a grid, actually, of PMv3 is implemented or not. So you have, like, imagine on the X and Y axis, there's a box with four different boxes. On one side is whether or not PMv3 happens, and on the top is whether or not the price of Bitcoin Cash is over 10,000 in a year. And people can bet on individually each of those boxes, and by looking at the sum total percentages in each of them, you get a good sense of actually how variable X affects variable Y. So if it's implemented and the price is over 10,000 is like 10% higher chance, we then can assume that the market believes that PMv3 will increase the price, that has a 10% chance of increasing the price beyond 10,000 within a year. And you can get much more complex. That's a very simple example, but you can get much more complex. You can have scalar values, actually. So it's not just yes or no values, but you can have, the market can actually indicate to you exactly how much it thinks it will increase or decrease the price in that time frame. And there might be other time frames that are also measured. So information markets, like prediction markets, I think are one of the most important, probably will be one of the most important creations in the coming 100 years. And they've been not very possible before we've had, as much computing power as we have, and also consensus technology as we currently have. So there's sort of a convergence right now where the technology and our knowledge of the topic have gotten to a point where I think in the next 10, 15 years, I expect prediction markets will become a much bigger part of our world. And I've written a whole lot more about that, actually, at this link, prediction markets on Bitcoin Cash. Oh gosh, that's not there. Here we go. It's right here. That's funny. I'll fix that link. So this is a much more detailed explanation of what's going on, and also a bunch of the other things prediction markets could help with: health and medicine, scientific theory and discovery, environmental protection, management of public corporations, marketing and consumer protection, insurance and disaster prevention, software security, news and media, transparency, empowering whistleblowers, breaking propaganda and reducing violence. They have a lot of promise. And I write even a little bit more about why I think Bitcoin Cash should be particularly interested in making sure prediction markets work on Bitcoin Cash. Because if the dollar was crowned as the world's reserve currency for its use in basically in global trade and oil, I think there's a good case to be made that its successor will be crowned for its use as a reserve asset in information markets, and that is what we are competing over right now. So I think Bitcoin Cash is particularly well suited for it, between low network costs and good scalability. You can read more here, but reasonably good privacy. Bitcoin Cash is fairly good with that, and then also deflationary I think is quite important for a well-functioning prediction market. So yes, I encourage you to take a look at this blog post if you are curious more about the prediction market stuff. But that summarizes these use cases.
Great, thank you. So I appreciate your going through that. And Richard, before we get to the comment that you had, I would like at least to open it up to anyone to comment specifically on those use cases. Does anyone have any thoughts on the applicability of those use cases, or whether they're likely to be valuable or possible or anything like that?
I mean, I'm interested to know from Jason whether like what you think of other prediction markets not exploding that we've seen on, for example, Ethereum. Is that because of the transaction fees?
Probably. I imagine prediction markets are going to take a while to get big. I mean, in the same sort of curve as internet usage and computer usage, really. The places where prediction markets get really interesting is where they start to have an effect on sort of the social fabric of the world. Right now, people go to the news if they want to understand some, if they want a summary of some current events. And I think that in the next 20 years, I'd be very surprised actually if people didn't look to prediction markets actually for a much better understanding of where reality actually stands, where news can be quite biased. Numbers and markets are not going to lie about their about actual probabilities. So where the news can actually make a mountain out of a molehill, and vice versa, they can totally cover something up that is not highly important to society. Prediction markets, I think, will help to allow people who are not necessarily experts in something. If you're not an expert in quantum anything, but if the news says again that we finally got a quantum computer, you can immediately fact check the news by checking, have the prediction markets actually resolve that this is the quantum computer that breaks all of traditional cryptography. And you'll find, no, yet again, it's no. And the news is just trying to get you to watch again. But things like that are going to, I think, fundamentally, very fundamentally change where people consume their information. And those things take time. They take generations. So, in the next 10 or 15 years, we might have a big growth in prediction markets. But 100 years from now, prediction markets are going to be, I think, one of the world's core information sources, and they'll be very, very good at it. So a lot of things where uncertainty destroys a lot of value in the world today, I think prediction markets can actually can save a lot, and goes back to some of those examples I was just giving, disaster prevention and stuff. There are a lot of disasters that could be averted if people knew what information to look at, and prediction markets make that very sharp, because they are a number. There's no beating around the bush. If an expert believes something that the world should know more about, they can help to make a new market that surrounds that belief properly, or highlight a current one, and they can actually become fabulously wealthy if they know something that the world doesn't, and they help the world to understand it.
Thanks.
Yeah.
And so, you mentioned the transaction fees and also the inherent difference in scalability between the UTXO model and the account model. Are there any other technical reasons why you think the prediction markets and also the other use cases that you outlined will work better on Bitcoin Cash with PMv3 rather than something like Ethereum?
Actually, and I'll interrupt you just real quick, Jason. Would you mind unsharing your screen, because that'll give us the faces back. There we go.
There we are. Very much. Yep. Yeah, I'll switch this back over here. Yes. So, and I would say specifically a good example actually of where kind of the limitations of Ethereum have sort of hindered the uptake of existing prediction markets. Several of the existing prediction markets have actually had to change several of their algorithms to make them reasonable on Ethereum. Now, side chains, so rollups in Ethereum, as running Ethereum in a side chain would allow some of that scalability stuff to come back. So I wouldn't say that that prediction markets are impossible on Ethereum, though I gave the rather prediction markets are impossible to get really big, like I was describing there. With rollups, they're the sky is the limit there in some ways. However, there's still a lot of work to be done, and a lot of the existing prediction markets have spent a lot of their development work in the past few years making it work on the Ethereum base layer. And in a lot of ways, they're going to have to kind of undo the work that they've done there by they've simplified their market scoring rules. A couple of them don't even really use a market scoring rule anymore. They just use kind of a bidding system. There are market scoring rules which we know are better for prediction markets, which are simply not implementable on Ethereum unless you do it on a layer 2. And that part of the reason some of these prediction markets have had so much trouble there is because they have been spinning their wheels on that implementation issue, just that level of implementation. So other than just the, I mean, even just recently, there have been times when it costs several $100 in 2020 US dollars to create an account or so on these prediction markets. And then, you know, if you have to pay $50 a trade, you are pricing out a lot of your potential market and therefore potential profits. And then you have your chicken and egg problem of why would experts bother to go and set up on this market if they're just going to, you know, share their knowledge, but make, you know, $5 on it. And if they pay it all on transaction fees. So there's all sorts of stuff like that where I think the flywheel has not really been spun, but in part just because there's a lot of implementation issues that have to be worked through. So in a lot of ways, those implementation issues, the road is now clear. However, they still have a long way to go. So I think it's actually going to be very competitive, probably, for new prediction market efforts to begin on Bitcoin Cash. They're not very far behind what exists already on Ethereum.
And do you think that those same principles translate to the other use cases as well, or are these specific to prediction markets?
Yeah, well, and specifically in the case of synthetic assets, decentralized transferable synthetic assets, one that you can make a synthetic asset with any price feed. The issue is how much you trust the price feed. And if you look at how that market has developed, the Ethereum world is not far past even the current BCH world, just with any hedge and D token. Right now, any hedge and D token, the price feed is trusted, semi-trusted at least, and that is basically the state of the ecosystem also in Ethereum. So there's maybe the design is a little bit more advanced in some places. I mean the visual UI design, but you know, under the covers they're practically equivalent right now. So the primary difference between the current BCH world there and Ethereum is that those synthetic assets are transferable in Ethereum right now, just due to this being able to validate backwards thing. But that it's also not really much more developed. The most advanced oracles, so far as I'm aware actually right now, are basically multi-sig contracts. Like if 4 different companies lie, then the oracle still falls through, right? So there has been a lot of work done in Ethereum, but I would not say that Bitcoin Cash is far behind, even if we're starting from scratch.
Cool.
Yeah.
Very good. Well, if there are no other comments, then let's move on to the costs and risks involved in this upgrade. Now, let's see, excuse me, I'm going to bring up the page I was just looking at. But if you could walk us through, you know, what implication does this have for various participants in the Bitcoin Cash network? So users, and then businesses, and then, you know, consensus level software. What is affected by this, and what will the costs and requirements be?
Yeah, awesome. So this is a consensus change. So all full nodes will have to update. It's table stakes. Then this is a little bit more. This is a little bit larger of a change for the ecosystem than, for example, like a new opcode, because with a new opcode, all you need to do is have the nodes update, and most wallets and validating software, most SPV wallets and indexers, things like that can usually ignore them. In this case, the footprint of what is going to have to be updated is quite a bit larger. I would call it a moderate, where all indexing software, this is stuff like Blockbook and Bitcore, things that are the server side software that provide APIs for end wallets, that stuff will need to be updated. And then SPV wallets, so Electron Cash, Pocket, things that are themselves validating the actual state of the chain in some ways, because they also are validating, they're also parsing and validating transactions. Those pieces of software will also need to be updated. So any software which parses transactions, it will have to be updated. Interestingly enough, most wallets that most users are using themselves don't parse transactions. So I would call this moderate, a moderate change. This is actually, just to give you an equivalence, it's very, very similar to the DAA change, the difficulty algorithm adjustment change. Very similar to, I guess that was last May, I think. The footprint of software that will need to be updated is very, very similar to that. As opposed to, I'd say the most breaking or most difficult ecosystem change would be, I would call high. A high change would be wallet software and signing software itself needs to be updated because of how you're changing the signatures. And that's only happened once in Bitcoin Cash. That was the fork change. That was when we applied the BIP 143, the signature stuff in 2017. But this is quite a bit less breaking than that, but still quite a bit more than opcodes. So right in the middle of ecosystem difficulty. Pretty much all consensus validating software will need to be updated to support this version 3 transaction format. Fortunately, it's very similar to the current transaction format. So in a lot of cases, it's probably just going to be like copy and paste and then copy this section twice more for the 2 additional fields that are at the end of these. But it still requires an update. Fortunately, it doesn't necessarily require an update for wallets themselves, or especially for hardware wallets, for the hardware devices themselves. There will be no firmware update there. It will be only the server side API that is pre-parsing the transaction before it comes down. That stuff will need to be updated. There is a review, if anybody's curious. There's a review in the Bitcoin Cash research forum where I went through and broke apart a lot of the existing wallets. So the BitPay wallet, Bitcoin.com, Edge, Jax, Exodus, a few of the others, Trezor, Ledger, those should only require updates on the company's servers. They shouldn't require the user to update their wallet because the company's server parses the transaction and sends it down either as a JSON or as a gRPC call. Then the user's wallet just asks the server for whether it's UTXOs, and the signing doesn't change, and version 1 and version 2 transactions will continue to be possible and interchangeable. You'll be able to send money in a version 3 transaction, and that wallet doesn't even have to understand the version 3 transaction. They just have to know what the UTXO is, and they get it from the server, and they'll be able to send that money in a version 1 or version 2 transaction. So from the user's wallet perspective, they probably won't have to know anything about it. It's just that the back end that supports those wallets will have to be updated to the latest node version. Obviously, like they have to be updated after every change. But then also, if they have any indexing software that's doing parsing separately from the full nodes, that will also have to be updated. So it's not an easy change, definitely not an easy change, but it's not insurmountable.
Very good, thanks. Does anyone have any comments on that generally, or whether they think the trade-offs are worth it? Ben, go ahead.
Yeah, so a little bit of clarification, and also I'm curious what Jason thinks about this. What the scope of what Jason is talking about is these are the changes that are necessary for the ecosystem in order to stay on the chain and still operate, right? For doing what you're doing today. But I don't believe that is sufficient for, as far as changes for being able to participate and do all the cool things that PMv3 is going to do. Like if I want to participate in this prediction market, my wallets are going to have to be really advanced. What have you thought as far as how this is going to evolve? I mean, like right now, few wallets can even support the simple complexity of the SLP tokens. And now what you're talking about is like, wow,
Yes, thank you for bringing that. Yes, so in order to use this stuff, wallets will have to be updated to use it, and it's actually hard to even thoroughly envision what the whole ecosystem will look like because we're talking about quite a paradigm shift in what's possible. So I've spent several months now trying to figure out what that might look like. We're actually a couple of years now, but yes, wallets, in order for wallets to participate in this stuff, they will also need to be updated in a lot of ways. A lot of the so those are the places where the Ethereum ecosystem is quite well developed already, and where we've got some catching up to do. We'll probably, a lot of our existing libraries have basically fixed transaction construction methods that are hard coding exactly what the contract should look like, and that's still fairly common across the cryptocurrency ecosystem. So I imagine we're going to get kind of the first wave of wallets that have generalized transaction construction support. That exists now in the libauth library that I'm working on. So there are some examples there, and CashScript, Rosco's stuff, also gives you that ability. So we are getting there, but there's definitely a lot of work to get wallets where wallets can support adding a new authentication scheme, basically. And even if the developers of the wallet aren't terribly familiar with how various on-chain applications work, you want users to be able to import an authentication scheme that they trust and want to use, and be able to communicate with separate networks there. And there's a lot of these networks are going to be sort of separate peer-to-peer networks that are one-to-one pegged with BCH, where they happen on a side chain where they scale independently, but then their value transfers settle back to the Bitcoin Cash chain. That'll probably be the most common way that the really big stuff, the fanciest prediction market stuff, will probably happen. So a lot of that is going to, there's going to be a lot of development to do for wallets to provide those APIs and things, provide those nice user interfaces for synthetic assets and prediction markets and stuff. There's a huge field of new development and UI work to do there. But at least in the immediate near term, the changes aren't immediately required of the wallets themselves. It's just if those wallets want to provide those new features to users.
Do you envision
jump in there? Oh, sorry.
Go ahead, Tom.
Oh, thank you. I just wanted to jump in and say that the whole idea of a wallet, as we've been using it in Bitcoin for a couple of years, is extremely limited. We just look at it as money. And that makes total sense because, we still have the floppy disk for saving as an icon. People understand it. But when we consider the fact that the only front end for the entire Bitcoin Cash concept is what we now call a wallet, then we have to realize it's going to have to do a lot more than just be a wallet. You're going to have an entire payment solution. You're going to have all of these items in there, and it probably is going to be several years of development, and not just the new features that we add there, because just adding new features means that only developers are going to use them, because it's going to be the user interface that is going to be the hard part to make. It's going to be the interesting part where we turn it into a product, and the product is going to be ready for end users. And that's going to be something that we're going to see happening in the next couple of years. And I think that is going to be the actual test of when we break through, when Bitcoin Cash is going to be seen as serious, because that's going to be when we start seeing a lot of people seeing the value outside of just the developers and the experts.
Yeah, definitely. Yeah, there's a lot of development to be done there. But it's one question that I have. I don't know if wallets will be sort of an all-inclusive kind of a new category of applications. That's kind of the way the wallet ecosystem has developed so far in Ethereum and elsewhere, is that the wallet is this kind of category of application. But it's also possible that we'll continue seeing the current crop of wallets continue being kind of just a money thing, just sending and receiving money. And then we get a new crop of applications that are your decentralized brokerage thing. So it's like almost like your brokerage app. Right now, you use a lot of people use a different app for their banking stuff different from stock brokerages. And there might be a wallet that is focused on those synthetic assets, transferable synthetic assets. There might be an app that's focused just on prediction markets. And then there'll probably be wallets that have plugin systems that let you install the prediction market app that is developed by somebody else to work in the plugin. So I'll be curious to see how that part of the ecosystem actually develops. If they will be separate apps, kind of like the world currently works, or if these wallets will build plugin systems and try to extend that way. And I don't know. We'll see.
Yeah, I think to make such a thing like that possible, we're going to have to go through the similar kind of evolution that the Ethereum did with their ERC. They got their ERC 20 for fungible tokens standard, right? How do you call it and interact with these? You got 721 for non-fungible. You got 1155, so you can combine them all together and make them discoverable. We're going to have to do something like that, and which is also kind of interesting because there's been some scuttlebutt on some of the BCH chat about some developers are kind of frustrated that BCH isn't moving fast enough, and how am I going to innovate and get a first mover advantage on Bitcoin Cash because it's so slow to adopt, and it's like when this thing goes live, brother, good luck.
Yes. Yeah, that brings up a good point. So what really is happening? We're getting this detail about the transaction format sort of out of the way, so that developers. Right now, in order to make something happen on Bitcoin Cash, you need a proposal that will happen during one of these scheduled upgrades. Right now it's a yearly cycle now. Once this is out, most developers will not need to have a network proposal to have a new token standard. Like they'll just design it in the contract language that is already supported in Bitcoin Cash. So in a lot of ways, this brings a lot of network level protocol development work. It makes it part of what is possible to do in user space, sort of on the system, in the user land, what software developers can write and deploy today. So our speed of development hopefully will be quite a bit faster, and it will be driven more on the wallet side, definitely, than it is currently, where it's driven on what we can add to nodes and get everybody to agree on and deploy at the same time and all of that stuff. Yeah, so that's a good example.
I've got a couple questions from the YouTube chat that I think are relevant to this section. So from Mr. Tester01, he's asking, are there any projects that PMv3 will make obsolete? And maybe they mean within the Bitcoin Cash ecosystem, but also maybe not sure.
I wouldn't drive a stake in anything. right now. No, I don't think so. Almost everything, I can see some upside outside of PMv3. There's, yeah, so Smart BCH allows us to run Ethereum stuff on a sidechain of Bitcoin Cash. That's a perfectly viable decentralized application of its own. It's likely to use PMv3 here in the next few years, I'm sure, just to be able to have a less trusted peg. There's other proposals, other VM proposals are certainly good to continue working on academically. There might be much better ways of doing this than Satoshi designed in the first version. We're just kind of extending the thing that Satoshi already designed to work for this other stuff. Group tokens, there are a few use cases where you could cut quite a few bytes from certain types of transactions if we did some sort of hard-coded solution like that. So that's, viable for more research. And then there are lots of opcode things that are still useful even with this. This will allow us to build pretty much anything we want. The limit is our ability as engineers to figure out how to make it happen. But at least we've kind of closed the loop on there are certain areas of development that are currently not possible at all and clearly not possible. But with this, it's going to be a lot harder to say that, like, yeah, that's not possible on Bitcoin Cash. Like it's much more likely that no, I haven't figured out how to do that on Bitcoin Cash yet is the answer. And for anything that I've thought about for long enough, I've not yet found something that I can't figure out how to do on Bitcoin Cash because it is quite powerful already. So it's kind of just a matter of us getting to that development. But yeah, so I wouldn't say there's any proposals that I know of that this kills, that this totally deprecates.
Sorry, give me 1 second to find the next question here.
Well, I'll jump in. Can I just add something?
Sure, go ahead. Absolutely.
Which is that I think, to the contrary, there are projects, I'm not sure about proposals, but I'm sure proposals too, but there are a lot of projects that PMv3 will supercharge. AnyHedge comes to mind and SLP comes to mind. So for example, on SLP, an upgrade to the SLP protocol could allow miner enforced tokens. So I don't think SLP will become obsolete. I think SLP will evolve to leverage PMv3 and then be one of the token standards or implementations out there. And that's really exciting for SLP, for example. So I see it as a supercharging technology rather than something that's going to obsolete other projects.
Yeah, totally.
Sure. Thanks for the perspective.
And making SLP work on those decentralized exchanges, for example, SLP needs to be contract validatable if you want the decentralized exchange to be able to confirm that you're selling an SLP token. So things like that. I definitely imagine that SLP will evolve. And we can find ways of migrating in a like backwards compatible way, sort of. There's some clever ideas of like dual validating where we can have kind of an intermediate version which works with existing SLP wallets, but also starts to work on the contract validatable side as well. So yeah, there's a lot of the existing stuff we can definitely retrofit and upgrade to make work better with these decentralized things.
So from emergent reasons, given a shared state like a prediction market, atomicity won't be a problem because of the fundamental BCH UTXO design, but will there be competition for redemption of some UTXOs?
That's a great question. And yes, if you design your application such that it's vulnerable to that issue. It is definitely possible to design your application where it is not. So in some cases, you'll be able to sort of shard the application itself across multiple UTXOs. If you think about how the cash tokens demo works, and you can check that out on my blog, and there's a post about it. And also, if you click through the cash token demo, it includes a lot of comments. So it is inline commented all the way, includes a lot of kind of high level summary and then also just the details on why we need exactly this validation here. But the cash token demo is an example of that. The cash token demo lets you mint a new token, a new cash token, which is just, I've made up a token standard and I just designed it in script and I could deploy it today if PMv3 was already on chain. It's actually an example of like a token system you can design with PMv3 that I didn't have to go and get support for and get the entire network to upgrade at the same time. Much more possible to get big changes and fast innovation that way. But cash tokens, the cash token demo allows you to mint a new token and then send that UTXO to someone, and they can send it around and they can actually send it. It can be sent to a multi-sig wallet and sent back to another one, whatever. And eventually you can bring it back to the contract and you can redeem it with the contract to get your money back. So you can deposit some money, get the token, move it around, and then redeposit the token and get your money back out. And that's not a terribly useful application, but it demonstrates all the primitives you need for really important things like depositing money to a prediction market and doing the prediction market stuff and getting and withdrawing your earnings or whatever. But the cash token demo is a good example of that sharding capability because the top level covenant has information about all the tokens, and we mint tokens, and then people can actually move those UTXOs around independently of the top level covenant, and eventually they turn them back in. And each of those have their own history and their own competition over the UTXO for that piece. But only when you turn it back in is there competition over the top level UTXO. So that's where this makes it a little more complicated for developers to figure out like how the scaling actually works. But it's a problem that the developers have to figure out rather than a scaling problem for the network itself. So it's, we picked the side of the trade-off where the network stays stable and instead developers have to work a little harder.
And could you elaborate on just what actually we mean by competition for redemption of the UTXOs?
Sorry, yes. So in this case, if there's a covenant, if there's a public contract somewhere where there's a pot of money on the chain, which is the prediction market fund, and you can send money to that address, and you get that money in the prediction market. That you can deposit money, and then you can withdraw. And there's a withdrawal strategy I've described in the blog post too, where you have a quarterly withdrawal setup where the shareholders, so to speak, of the prediction market validate these withdrawals. But the issue, the UTXO, the contention issue we're talking about is there's that pot of money that exists on the network, and there might be multiple people in the world at any moment in time who want to do something with that UTXO. They want to like execute that mint contract, or they want to redeem. So in the case of the cash tokens demo, there's contention over if I want to mint at the same time as somebody wants to redeem, both of us might send a transaction. In Bitcoin Cash, whoever sends the transaction first that's what will propagate across the network. And then in the case of the cash token demo, that's a good example of where the contention isn't actually an issue, because like I'll mint my token, and if you deposited a couple seconds before I wanted to mint, whatever, I'll just build on top of your unconfirmed transaction, because why not? It doesn't affect either of us. So that's an example of a contract where the contention isn't a problem. The contention isn't something where we're going to try to go get a miner to undo his transaction so I can put mine in first. And that's a contract design thing. You want to design your contracts to where contention doesn't benefit any of the players in the current block. And it's actually not too difficult to design a contract where all of the contention in this block applies in the next block, so that as long as everybody gets their transaction in now before the next block, we all get the same price or whatever. And you can design your contract to work that way. In the case of prediction market, like I think in the case of a lot of more complicated stuff, things like decentralized exchanges and prediction markets, I think what's ultimately going to happen is the virtual machine language is not a great language to design very fancy stuff in. And so neither is the Ethereum virtual machine. Like you don't want to write your code for a lot of stuff in these blockchain consensus algorithm virtual machines. You want to just write it in like Rust or C++ or whatever. And you run it as a separate peer-to-peer network. And then you create the peg where you can deposit and withdraw from that network, you create that in the virtual machine language. And that's a much more easy to review. It's a much more tractable problem. It's very easy to, it's much easier to do it that way. And your development speed can be a lot faster. So I think a lot of, and then of course you still have to figure out contention on your network. But a lot of those issues, they're the same ones we've seen in a lot of, we've seen them in Ethereum and elsewhere also. But yes, I think a lot of that is tractable, but it is a very good question because it's something the developers have to think about. You can't get around thinking about it.
Very good. Here's one from Imaginary Username. Have you evaluated DOS, so I assume denial of service possibilities of transactions consuming disproportionately high amounts of resources compared to their size? I assume he means computational resources.
Yeah. Yes. And actually, the best place to look for a summary on that is actually the virtual machine limits chip, which is totally unrelated to this, but I just released it like a couple of weeks ago or something. I dug into that very deeply and confirmed that the primary, just to summarize, the primary concern for resource usage is signature validation and hashing. Like that's it. Practically everything else is not even like a rounding error. It's actually sort of funny. The operation limit and stuff doesn't really make any sense in the Bitcoin system. It's clearly something that like Satoshi thought about a little bit, but like I'm sure that if he spent more time on it, that is one part of the system that would be a lot more polished. The operation limit is basically useless outside of signatures and hashes. So we can calculate exactly the most expensive transaction that's currently possible to broadcast on the network, and that's actually in the chip. It's marked under the benchmarks. And if anybody has a way of optimizing that to make it more expensive, please let me know. I've tried to optimize it. So I've tried to demonstrate exactly as expensive as we can make it. And the cliff notes is that it's just not expensive anyways. Like it looks, these days especially, computers continue to get faster. So the average 2015 CPU could validate a full block 32 megabyte, or actually I think 128 megabyte block of those transactions can validate it in like 5 seconds or something. Of course, and we've got 10 minutes to do it as if they're coming in over the time. These days, just the difference between an average 2015 CPU and a 2018 CPU is now 6 times faster. So like we're talking about by the time PMv3 happens, that worst case block will be even faster to validate. It's going to be sub-second. What it means is that in reality, what's actually limiting us is the size, is the storage space basically on the network. And right now, the cost of storage with the fee of 1 Satoshi per byte is approximately 1 BCH per 100 megabytes of block space. And in an attack which tries to exhaust resources in hashing or signature validation is almost like if you were running a node, you probably wouldn't even notice the attack happening. It would just look like somebody's filling up the blocks. Somebody is paying to fill the blocks, which is possible with op return.
I can confirm the attack factor as well. It's essentially the only thing that really matters when you're validating a lot of transactions is disk I/O, because the waiting for the data coming from disk is a million times more than the actual CPU doing the work. It's we got to the point where parallel validation is relevant. Parallel disks and all that kind of stuff, that is much more relevant. And yeah, what you said, it's really not that big a deal.
Okay, and then one clarification. So really, we did touch on this, but can we just clarify, so which things have to be updated in order for this transaction format to work on the network, and then which other things don't have to be updated to keep functioning, but do have to be updated to use the features? Could you just give us a quick overview of that again?
Yeah, all nodes will have to be updated. And then kind of the Cliffs Notes with anything that parses transactions on the network will have to be updated. usually that's going to be the backend indexer that supports a lot of wallets. So Blockbook and Bitcore, and then a few, I'm sure there are plenty of proprietary ones that are asking nodes for information and then sending that information down to wallets. That stuff needs to be updated. What doesn't need to be updated is wallet signing code, and usually wallets, if the wallets are asking for UTXOs in a pre-parsed way. So I imagine probably Electrum server, it'll depend on specifically Fulcrum servers and stuff. It'll depend specifically on the piece of software, but a good way to check is, does this piece of software parse transactions ever, if it ever parses transactions? And if it does, typically it'll need to be updated unless you test it and it doesn't break when it gets a version 3 transaction. As long as it doesn't break, then it's fine. But most software you're going to want to double check. So like we're going to need to carefully look at a lot of that stuff. But the hardware signing devices or wallets that are on offline devices, offline computers and stuff, those things do not need to be updated. That was the biggest hassle of 2017 and still a hassle for a lot of systems that are not even updated yet. Being able to sign for BCH transactions in an offline signing system that has been around since 2013 or whatever. Things like that we do not need to update. But the fast way to know is, does my piece of software parse network transactions, and will it break if it gets one that is not valid in the version 1, version 2 format?
Can I add to that?
Yeah.
So, and the reason why it's only software that parses transactions is that all PMv3 does is rearrange the contents of a transaction. It just moves some things from the middle to the end, and that's pretty much it. It's like a syntax change with no semantics change. Like, it doesn't really change anything beyond this, and that's why it's called a transaction format. It's just the format. So if you're reading raw transactions, then you need to upgrade your software. But every transaction in PMv3 still has inputs, outputs, the same semantics. And that's what's so brilliant about PMv3 is that it's literally just a rearranging of fields in this format. And then it enables things like inductive proofs. Like, inductive proofs are not a sort of first-class component of PMv3. They're something that you can do in userland if your transactions are arranged in this way. And so I think that's what makes it such a clever hack, is that it's really just moving a few things about, and then all of this extra stuff becomes possible in userland. You're muted, John.
Thanks very much. Sorry about that. So from imaginary username again, if an indexing backend does not plan to support version 3 transactions, can they not upgrade?
Yeah, I think the short answer is yes. They will have to upgrade in order to stay on the network. So if they don't upgrade, then they will cease to be serving the network at all, because the network will move on without them. Fortunately, as far as I know, they're all open source. So it's just a matter of, it's the same issue of every time we have an upgrade, exchanges need to upgrade their node software, and wallet backends need to upgrade their node software. And in some ways, it's basically the same issue. Everybody's going to have to upgrade their backend node software. We can send pull requests to any open source indexing servers and stuff, and those are going to be fairly simple, because we're really just moving around some fields. We're using an existing hashing algorithm that's already being used in the transaction. Like, in general, things are very, very similar. But yes, it will. Anyone who is running some backend system that is supposed to be in consensus with the BCH network, exchanges, wallets, backends, and things like that, businesses that are running their own servers and stuff, they will have to update for the May upgrade. But it's something that most of them will just do exactly what they did a couple of weeks ago on May 15th. They'll upgrade to the next version and they'll be done. So we'll have to get some of those indexing servers. It's more complicated because the software that uses the nodes in a lot of cases will also have to be updated, simply because it's not been designed to be able to upgrade the version format in the future. Like that's not something they were thinking about when they were building the indexer. But by and large, it is a simple patch for practically anything, just because we're not changing much at all.
Okay, and it looks like there might be some confusion as to what the intent of the question was, but we wanted to clarify that it's specifically about indexers that want to ignore version 3. Is that a possibility?
Indexers that want
and if you're not sure what that means, I'm sure we can cover it another time.
Maybe I'm probably not understanding the question, but in general, there's not really. Okay, you could choose not to, in the indexer, you could choose not to also index the new detached proof field, but in a funny way, actually, there's only one field you'll index separately, and then detached proofs is actually a Boolean switch. It's either on or off, and that's kind of the only new piece of information is there, except for the detached state. So there are a couple changes. But maybe simpler than I expect you're thinking to update an indexer.
Are there indexes that don't actually pass raw transactions that would sort of bolt onto a full node and actually receive the transaction data in a non-raw form? I'm thinking of BCHD's gRPC interface.
There definitely are. Okay. I think the ones that are, though, are asking over the RPC interfaces generally. So they're either asking for a raw format or they're asking over the RPC interfaces. And in the RPC interface case, as long as the node is updated so it doesn't break that API, indexers could just ignore the new fields, obviously.
Exactly.
Yeah. That's where you're right. That's where I was thinking differently. The indexers I'm thinking about parse raw transactions, and that's why you wouldn't be able to ignore it. But indexers that are just reading from the RPC, they can definitely ignore it. Yeah, that's correct.
Very good. So we are probably getting close to where we should finish this up. So let's talk a little bit about now stakeholders has already been covered a decent amount by who needs to change and who needs to update. But could you tell us a little bit about any efforts you've made so far reaching out to stakeholders, or if you've received any public support, or if you've not, what your plans are to reach out to those stakeholders?
Yeah, so we're still kind of solidifying the. We want to make sure the spec is really, really right before we try to get people to commit to things. We've gotten a few. There's definitely a lot of those stakeholders are excited about it, but we're going to leave it at there are no public commitments yet because there's no reason for us to start drawing battle lines. But once the spec is there are a couple of details actually that the reviewers on this call have helped to identify that we want to improve. But I imagine in the next hopefully in the next month or so we should have everything really settled. And then that includes a lot of the kind of end use cases. In some ways, where there's a lot to think about, because we're thinking about not just what the spec itself looks like, but then what we can do downstream with it. And we've spent a lot of time now in the past 6 months actually thinking about what we can do downstream with it and making the software libraries work with this stuff and on all that stuff. And so we're just making sure that all of those learnings have made their way into the spec. And that's just taking a little bit more, development and review work. But yes, I think that in the next, hopefully in the next month or so, we should be in a place where we're ready for people to sign on and provide endorsements and things.
Very good. And maybe one good question to sort of leave this off from Eleanor Blanc. She's asking, so she hears a lot of support for this new transaction format. Has there been any contention that you've seen, any dissident voices or, people that have just, not wanted it, or maybe even hypothetically, who might not want this, someone who would not benefit specifically?
Well, it's quite nice that it's just a format change. That all of the contention so far, there's been a little bit of contention over like the details of how I proposed the original version. Specifically some of the number formatting stuff. In order to make this stuff work, we need to make numbers work in the virtual machine. And but all of that contention is represented on this call pretty much, as far as anybody who's come to me and talked about it. And we're still, that's the part actually we're still figuring out. It's really like some details that aren't going to be terribly important to most of the people listening on this call, but we want to get really right. So we want to make sure we like how we encode numbers, or how we choose to solve the number encoding incompatibility that PMv3 tries to solve. So yeah, it's sort of funny. The only contention so far that I know of is actually that specifically number formatting. I imagine we're actually going to just separate out PMv3 from the number formatting part of the proposal, and we will discuss that separately. But it is really application details that are. It's not the high level. We should allow a hash of unlocking bytecode. So that's good. It's quite nice that it's, as far as I know, non-contentious.
Very good. Well, thank you very much for taking the time to present for this network discussion. Thanks, of course, everyone else for participating, and to everyone who's watching both live and then later on YouTube. Make sure to keep up with the Bitcoin Cash network discussions by subscribing to our YouTube channel. Follow us on Twitter. If you have a topic that you think should be discussed, the place to go is bitcoincashresearch.org. And thanks to them for the work they do running that platform. And finally, thanks to all the folks behind the scenes who make these network discussions possible. There's a lot of people doing a lot of work that we don't see. So thanks to all of them. And then once again, thank you guys for coming.
Thank you very much.
Thanks a lot.
Thank you all.
Thanks, Jason. Thanks, John.